Just sort of two things to say before I start. The idea of using a large resource pool to run applications running on people's computers isn't a new idea. If you go back to the 60s, we had a mainframe with remote terminals that shared resources on the mainframe. And what we've seen over the years is sort of an expansion in the scope of that core computing functionality. So in some ways, when you sort of say cloud, what you're really saying is a convergence of technologies to make a large amount of computing resources available in a, I'd say, relatively simple ways. We're going to say it's not such a case. But it's also then it's sort of how the term cloud is being used. So when I first came across cloud computing, because I'm a computer scientist, so I play in that area quite a lot, obviously. And I'm also a complete geek. I love my gadgets. Cloud was all originally about communication and nothing to do about computing and data and storage. It was about being able to walk from one end of London to the other and have uninterrupted network access. That's what it was originally. And then slowly it was, well, let's maybe make data stores available. And really, for me, the transition to cloud is basically when the big IT companies grabbed it as a marketing term. So if they hadn't, we might be using the term as, galaxy computing or sky computing. So it's kind of a sort of synthesis of a good idea with a bit of marketing thrown in. So that's my sort of 10 pence of context. But it's definitely a term that's here. So what I want to talk to you about this morning is a new, I say it's new, it's been going since July, and it was originally conceived about a year and a half ago. This European grant that I'm running on called CloudSME. And CloudSME is all about trying to get a change in the way that we use and supply simulation to end users and practitioners, etc., by using cloud. And I'm going to give you an overview. And Russell made a comment about, I don't know how complex it is. Well, around about slide 5, I'll show you. So the co-authors, and this isn't the full set of co-authors, but myself, Thomas Kiss is the project leader. He's at the Centre for Parallel Computing at the University of Westminster. And that's great for me because I used to work there 20 years ago, so it's quite nice to come back there and work with these guys again. Peter Katchuk is a visiting professor there, but he's the lead at this institute called MTA Staki in Budapest in Hungary. And really, they've been driving research infrastructures in the European Grid Initiative for a very long time, so it's a very mature group. Then we have Gabor, your guess is as good as mine, I call him Gabor. He's a professor, he's the lead of the Centre for Parallel Computing. He took over from Steve Winter 2 or 3 years ago. And then Nicola Fantini, who's the CEO of an organisation called Cloud Group, who supplies some middleware that we use, I'll describe shortly. So overview, all very simple. If there's a fire, run. These are your highlights. I'm going to give you some cloud computing context that Stefan's already given you, but I'm just going to think that people got short-term memory, so I'm going to run through that again, ask questions later. I'll give you an overview of the CloudSME project, and being an FP7 European project, of course, there's a huge number of partners and all that, but I won't go on too much about that. I'll dwell on the CloudSME Simulation Platform, which for me is the most interesting part of the talk. And then I want to say something at the end about simulating cloud computing, because there's a definite point I want to make there. What I haven't got in the talk is the brewery template, so if I've got time at the end, I'll mention that. And is the demo up and running on the Sega stand?
It is, yeah.
Yeah, so Sega's involved in this as well. Maybe say something about that then. Okay, so all presentations about cloud computing usually start with this definition. I've decided not to. I'll give you the motivations instead. So in my area, you usually come across cloud from starting to say, well, how do you make things go faster? Well, the usual response, certainly in my university, is, well, I need money to do that because I want my kit. I want my cluster. You go around Brunel, it's the same in probably Southampton and all sorts of other universities. You have academics who have their pet clusters, usually in a cupboard in their office, overheating. They need tending like sort of irascible ants, and They don't usually work together, but it's mine. I can do anything I want, and it's there on demand. So I buy hardware, and hardware makes me happy because I like kit. I then hire more people to manage and support the growing clusters, okay, or networks of PCs or whatever. So I'm being an academic, I get research fellows, and I worry intensely that in 2.5 years' time I have to find another research fellow or continue the grant. So it costs more money to do this. And then I build cluster after cluster to power mission critical applications. So you end up with sort of large data centres which are extremely costly. And if you're Ford or whoever, you can afford it. But if you're an SME, you can't really do that. So the problem is low average utilisation rate. So I've got a big problem, but that problem only exists for a short period of time. And if I've got the clusters, it exists for an even shorter period of time because I can run things faster. So I now have a very large paperweight in my office, costing a lot of money to run, not really doing very much, and is already obsolete. Wasted capacity. There's loads of things. There's loads of wasted capacity in my cluster because it's not running. One of my little bugbears about UK universities is there's loads of PCs in all these unis that, as a taxpayer, I've paid for. I'd love to be able to use that spare computing capacity for British industry, instead of, say, Facebook or any number of applications that our computer science students use. Out-of-date hardware. I mean, I can't remember who says this, but there is an adage that as soon as you buy a computer, it's obsolete. So being a geek, as soon as I buy something, I want another one. I want it better. I want to have more cores. I want to have GPUs. I want more RAM. And it's in my office, and I feel very happy when I see it gathering dust. Expenses to manage and maintain, particularly if we've got sort of more esoteric operating systems. You usually have people these days in universities, certainly in organisations who are good at running Windows servers. You need to revert back to Linux, Unix. It's a bit of a shift, etc. And again, too costly for SMEs. So, use cloud computing instead, and for those of you who've got good memories, lasting more than half an hour, this will look familiar. This is my version of the NIST definition. So, on-demand self-service. So, I need speed, I get it. How you do that is a little bit more complicated. Broad network access using more platforms. I always found that interesting coming into a definition about cloud computing, but that's just recognising that maybe one day we want to launch cloud computing applications from our telly. I want to optimise what I want to watch this week, go and work it out for me quickly. It's a silly example, but it's not unrealistic because, I remember somebody from Daresbury, which is a big physics institute in the UK, coming to visit Brunel 15 years ago, and he said the internet is dead. There was one of the times around about 2000 where there was a lot of these talks, and he said the internet is dead. Well, I don't mean that. The way we access the internet is dead, and one day we'll all access it through our televisions. And I said, what do you mean? Of course, now you buy a modern smart television, the least of the things you can do is watch TV. Whilst you're faffing with the applications trying to find BBC One. Then you've got rapid elasticity. Now what that means is I want 1,000 CPUs and I want it now and I want it for 10 minutes. And when I've done that I want to get rid of it. I don't want to pay for it anymore. And I get that instantly. Now that's the theory. In practice it's a little bit more complicated than that. But I get what I want. I can scale up and scale down. If I'm running a business like Amazon, I want to have more data centres, more data servers available to service my customers. If I'm nationwide, I want to be able to access more servers, particularly in the week of the ISAs. Everybody suddenly remembers they haven't got an ISA. Clearly, Nationwide doesn't have this system from personal experience this week, but it's sort of crashing. Not a good way of running a business, but there you go. Different business models. I buy a computer. It rots away in my office. I'd like to hire a computer. I want to use software. Usually you get software on a yearly license. I want to just pay for use. Now that is very simple to put, but there's a lot of debate about what that actually means. And certainly with the CloudSME Consortium, in certain ways we don't know what the business models are yet. And it's quite fascinating listening to the different ideas that are coming through. And then it's an access to high-performance computing, so general or dedicated hardware to speed up applications. So cloud technologies, again, Stefan's already said this, but I've got a pretty picture to go with it. It's basically you access it through a gateway. Then you have software as a service, so software deployed as a service in a cloud. And what that means is you have to do certain things to a software application so it runs on a server. And a lot of software I come across on a daily basis, that clearly can't work. It needs some work. And even when things have been deployed on a server, say for example NetSim and iThing, you've still got to do more work to it to make it interoperate with other software. You run platform as a service. Now that's all the gubbins required to actually host a service and provide something as a saleable service to a customer. Infrastructure as a service is the resources. So if you are a cloud provider, you'll probably run infrastructure as a service, and you've got all your clusters and servers behind you, running some software to allow people to host their services on that, and you charge for that use. And then you can have a gateway through to high-performance computing. So, and there's also, and I mentioned this in the paper, and Stephanie mentioned this as well, there's some people sort of coming together trying to say modelling and simulation as a service, and I think that's got some merit, because there are some things about simulation which are quite different to normal software applications. You've got different models, you've got different types of cloud, you've got private cloud, community cloud, public cloud, and hybrid cloud. Don't need to really go into that, just to recognise that companies offering clouds are different to universities offering clouds. All those are slightly different in the way you access things. Different resources. Well, I can offer a cloud which consists of computers having a single CPU, or 2 CPUs, or 4 or 8, or sometimes 16. And those have particular footprints which are very useful for different applications. I can have GPU specialist hardware, and I think Russell's going to say something about that in the next talk. So I can hire my GPUs for vector computation, for example, and then get rid of them when I need. Dedicated high-performance computers running MPI and dedicated parallel languages, and various types of different storage. And then just to make things even more user-friendly, we have different middleware running clouds, which are incompatible. So I could have a cloud running OpenStack, running some applications, but I can't easily port those to OpenNebula clouds. And there's loads of different ones. Amazon runs a different one as well. So, how can you create simulation applications as a service that are easy to use, can run on different clouds using different operating systems, can use high-performance computing, and can be easily reconfigured and interoperable? It's not easy. So this is why we came with our consortium, Cloud Computing Simulation, CloudSME. We're aiming to make that easy for simulation vendors and users. There are lots of people involved, lots of companies, and we're going to expand and bring in more at some point as a sort of user forum. But I'll talk about each of these in terms briefly. This is a really good case for cloud computational fluid dynamics. So lots of Monte Carlo simulation looking at fluid flow. So the companies involved in that, Ascomp is a Swiss company. They produce software called TransAT. The TransAT's used in oil refining, oil drilling. It's used in wind turbines. It's all about looking at flows through things. Each iteration of a Monte Carlo simulation takes ages for them. So it's a really good fit for cloud. They need speed up. Their end user is Eurobios, so they're a consultancy, uses TransAT to consult with the oil industry to solve problems. Process simulation. This is more challenging because simulations, discrete-event simulations, run quickly. So why would you want to use cloud? And this is Mark and Shane, in this use case, managed to convince them about a year ago to come on board with this this merry band. And we're still asking the question. So we're creating the technology, but it's kind of as a sort of, well, let's see what will happen when we do it. Because something which seems to come out of Stefan's survey is, well, if you can't do it, well, you won't do it. So the question is, if we had a different deployment of Simulate, what could we do with that? And one thing which has come out, which is very exciting, is the idea of web-based or cloud-based templates. So we're trying out the idea with a UK brewer. And the idea is that, well, are all brewers the same? Or if they're different, can we capture the core business so they can use, what would you say, simulation as a calculator?
Calculator.
You know, and so can we, and it's always like what the promise of web-based simulation was 15 years ago, but can we deliver that with a professional consortium behind them? Then we have the 3D insole design. I should be doing this. There's another diagram. This is all about shoes. Now, I think this is probably going to have the highest impact in the CloudSME project initially, because there's a very simple use case. There's a company who sells a 3D modelling tool. So you go into a foot doctor, put your foot in the cradle, you get a scan of your foot. That's then sent off and modelled. It comes back, it's checked. Meanwhile, you've gone off and done other things. So what we're trying to do with cloud is make that instant. So you get a scan, you get the 3D model back immediately. You check to make sure that's fine. And then you send off and you get an insole designed. Now, there's a huge number of people with foot problems. So the cloud, the added value for cloud for them is that they're going to be able to spread that out across Spain. And what they want to do is then reach into the Brazilian market. So I think that will have a big impact across the international boundaries. And then the last one, for now, aircraft logistics. This diagram doesn't really show it. The idea with that is there's a company that can gather real-time maintenance data for aircraft. And the idea is you use cloud to high-performance mine with the data to see where to put your spare parts. Because obviously spare parts cost money. So the architecture that we have, the CloudSME Simulation Platform, starts off quite nicely. So we have an environment called WSP grade, where basically you describe your workflow. Now, most simulation applications tend to be upload what you want to do, have it processed, and then give back the results. There tends just to be 3 boxes. But it's very simple. It's drag and drop. You put your boxes onto a pallet, you join them together by arrows, and the arrows indicate file transfer. You then open up the boxes and you specify what you want to do in the boxes. So the boxes initially are dummies. So you've got to put the tasks in there. So you describe what application is going to be used, and how it's going to run, and then where it's going to run. So you can't read this, but basically this is saying use Cloud Broker and use the Hungarian cloud. That workflow is uploaded to a server called the GUse server, which when called, calls the instance of your simulation software and runs it on the cloud that you specified. Now, that's the promise. As we know, the truth is a little bit more buggy than that. But as ever with these sort of software projects, it's sorting out quite a huge middleware stack. So the architecture behind that is we've got the P-grade user interface. We've got workflow storage so that you can deploy on your GUse server. Anybody else can have a WSP grade web application to access the workflow. You call it, run it, you get your results back. Nice and easy, but quite a lot of stuff behind it. Now, this has actually been developed for generic DCIs, distributed computing infrastructures. So you can actually pick up, and don't worry about what's down here, but there's a huge range of distributed computing infrastructures in addition to cloud that this system uses, because this has actually been set up for European research, and it's been redeployed now into simulation, or modeling and simulation. Now, if we select cloud, we then go to Cloud Broker, and just following Russell's, how complicated is it? Well, I'm not going to go through any of these boxes at all, but just to say that there's a lot of things that you need to do to manage your cloud. But the beauty of it is, you just see it at this level. So when you deploy things, I want to now deploy this on Amazon, you go back to this level, pick Amazon, and run. That's what the overall architecture looks, which I don't really like that diagram at all, but the idea is that you've got the end users, which in this case are Eurobias, Seika, Productiva, and Tomorrow. They've got their plug-in front ends of their software, maybe running in a web browser or connected directly into the application. Ignore the rest, up to this level where the software is deployed within Cloud Broker, and then there's specific deployments on a variety of clouds at the bottom. So there's a lot of work that has to be done first, but once it's there, the end user can pick a menu option and run. They've got a different version of this, where they call it the one-click version, the one-click architecture, I think it's called. That's it. Where you can say, right, set me up an infrastructure for 2 days and let me play around with it. And that's been delivered for an application called Autodoc, which is the molecular modelling software, and that works really nice and easily. So, winding up, cloud computing is highly complex. CloudSME Simulation Project is trying to simplify that. End users will benefit from simulation applications that make use of cost-effective elastic cloud computing, but it isn't simple. This is the byline I came up with, Mark. It's easy. So, excitingly, this is Simulate. This is the future. Starting here. It says Simulate up there, so you know. This is the preferences page in Simulate. And Mark did this unprompted. And my first response is, you sent me the use case document, where on earth is the cloud? And Mark added this circle down at the bottom. This is the vision for Simulate, that the end user doesn't see anything at all, really, apart from this box down here, which says, permit cloud to accelerate results. Now, we've got other ideas about that, which is kind of automating confidence intervals. So if you want to go from 95%, well, why not go to 99? You've got unlimited resources in the background. So we're experimenting with all sorts of different ideas and how to deploy that to the user. One of the things that we sort of ran in terms of cost effectiveness, and these are very raw figures, because we can't run this at the moment, so it's not quite there, but it's very soon. We ran auto-dock models, which take about 39 seconds a run. And we said, okay, let's run 1,000 of them using 100 CPUs on the Stacky Cloud in Hungary. We got a 48 times speed up, which isn't great, but it's okay. It's reduced the computation time from hours down to minutes at 2,500th of the cost of getting 100 processors. So 1,000 jobs running at 39 seconds, 48 times speed up, 2,500 times cheaper than buying the hardware itself. Okay, so that's a good line to end on, I think. So, thank you. Any questions?
So, some exciting questions for Simon then. He said it's easy. Yes, sir.
I would like to ask about licensing and, for example, Simulate has a license to buy. If you have to provide it as a service, does it imply more cost?
Well, this is, I could say within CloudSME we have a work package dedicated to sorting out the business model, but that would be a bit of a cop-out. We don't know. We don't know. There's a lot of sort of field of dreams to this sort of thing, that we're building these as a sort of a way to sort of maybe transform a field, but there's a lot of unanswered questions. So we could say, well, yes, we could have pay per use. Yes, we could give it away free. Yes, we could do this. Yes, we could do that. But it's largely untested. And one of the reasons why is that we don't know what users are going to react to this software. So I can say we could have a version of TransAT that is pay per use computational fluid dynamics. But until you can start playing around with that and see what the value is to your own company, it's difficult to see how you can justify it. Because at one end I could say, now this is a university researcher, it would be great to have a pay-per-use high-performance computing version of Simulate, but I would need to bid for that in a research proposal. And research proposals are more geared up to buying software licenses. If you're in a company, companies are geared up for annual maintenance fees and costs. You know, I'm going to go to my CEO to say I need 100 quid to run super fast on this application. I'll probably get a better response if I said £10,000 than 100 quid. But, well, we're not geared up that way because our accounting or year-end numbers don't follow that process. So there's lots of different factors in play. But if you look at cloud computing across, you know, outside of the project, there's no single business model.
Can I follow up from the Simulate point of view? I think it's genuinely the case that we really haven't a clue what to do about licensing. So part of the reason for being part of this project is to do a whole lot of experimenting and see what works. And I personally think that if we could just make cloud use of simulation completely free, then it would drive demand for model building, which will drive up our revenue anyway via dense constructions. So I ideally we'd make it free, but then you've got problems that, you know, the Amazon cloud is not free. So you've got to have some way of working out how you can charge for that.
Yeah.
But it's really open question.
And let's not forget that Simulator already has a cloud implementation. You can get it's U Simulator, isn't it?
Yeah, and now
Yeah.
we've made that completely free.
Yeah, so you can upload your models to a cloud. In this case, it's Amazon.
It is, it uses Amazon.
Yeah, but that's irrelevant. It's a cloud. It means you can deploy your models online, and Simulate provides that as free. You know, I mean, it's a question of using that example. Why would you want to run a 39-second model 1,000 times? Well, I couldn't sleep last night because I was trying to come up with the answer, and it's sort of, let's say you do 10 reps for a 95% confidence interval. Well, why not do 20 for 99%? That brings it down and sort of, well, it's really sort of doing two experimental parameters. So one has a range of 5 values, one has a range of 10. If you're doing 20 reps for each of those, that's 1,000 runs. I don't want to wait half a day for that. I want to have that in the next 10 minutes. So if you use 100 CPUs, you get that result back. And that's quite a compelling argument. And some of the discussions I've had with Mark, well, rather Mark's idea, is that if you're doing 95, well, transparently kind of not force the user to do 99, but just sort of have that on offer. Did you realise that these results are there? And sort of try and get community used to, well, Simulate does this as a matter of course. This is really cool. Why didn't Witness, why isn't AnyLogic, why didn't Flexible do that as well? So you get the demand out there, and then that they innovate, and that comes back to Simulate and all down the round. Yeah.
I mean, one potential area is in real-time decision-making using simulation, where you might want to little bites, but you then want the answer really fast. So perhaps a cloud-based solution might be very attractive.
Yeah. I mean, for our current 4 use cases, computational fluid dynamics, it's obvious why they need cloud, because those are massive computing problems. For the 3D foot modelling, I mean, it's, in some ways they need web hosting, but cloud just makes it easier for them to do it and to operate with the other tools, and that's good. Aircraft logistics, big data mining problem, right? So the one use case we have where there's a question mark is discrete event simulation, and that's quite fun because we don't know where we're going with that.
I mean, it kind of comes back to the argument between DS and SD.
Yeah.
One of the big benefits of SD is that you can use it with a client in a very interactive situation. I mean, if you could do that with a discrete event simulation, where you'd probably, most of the time, you're quite happy to run the simulations offline and come to the client with a proposal. But then, if you want to actually sit around in a room for a half-hour meeting, it'd be brilliant to just rent a quick
Yeah.
cloud for.
But when we're working on Sacred, I think we had the observation that if a model runs, then people are in the mindset, well, let it run, we'll come back tomorrow. But if you're if you can actually turn those around, it becomes tantalising. Yeah, that'd be really great. But yeah, to have a discrete event simulation and respond as quickly as an SD one would be great.
I mean, if you've got the chief exec in the room for 10 minutes and you want to do something quickly, then I can see that would be a really powerful tool to have.
Yeah.
Whereas most of the time you'd be quite happy just to run things overnight.
That's right. That's right.